Hello Vikings! Today we're going to talk about distance and displacement. We're going to define what a reference point is. We're also going to compare scalar and vector quantities, and we'll look at what the difference is between distance and displacement, and we'll work out a few problems. Okay, so we have been looking at motion because we were studying Newton's laws last week. What exactly is motion? It's simply when an object changes its position. So when we are making measurements of motion, it's important to know where a reference point is. And that's simply the place from which you measure or witness an event. And this is important because things don't always appear the same depending on what position you're in. And here's a prime example. Say you're in a car and you're driving down the road and you're on the highway. You might be going 60, even 80 miles per hour, and it may not seem like you're going that fast, right? Now, on the other hand, if that same car is passing by and there's a person walking on the side of the highway, and all of a sudden the car that's going 60 or 80 comes by them and they feel the wind, it is going to appear that it's going really, really fast. So your reference point may give you, depending on where it is, a whole different point of view. Okay, so what exactly is distance? We use distance all the time in our everyday lives. We will talk about how far we ran. We will talk about how far it is when we're going on a trip to go to another state, those sorts of things. So distance is simply how far an object moves. And we're going to use many different units over a lifetime when we are measuring to find distance. We could use meters, preferably, yards, inches, miles are something that we use frequently, and kilometers. Displacement is a little bit different. This is the difference between your ending point, wherever it is you end up, and the point that you started at. And I'll show you visually what this means in a minute. But I wanted to let you know first that when you're talking about displacement, you're going to have a distance amount, but you're also going to have a direction too. And here's what I mean. Let me show a really good visual. All right, so when we look at this, we have this pinkish dotted line. Okay, and let's say that this line, and you can see the direction we're going. Let's say this is an example of us going on a mountain bike trail. Okay, and let's say we've chosen to go to Cub Creek. And we can look at the green, dotted green line as a roadway. And we would have started at the top where the green and the pinkish dotted lines meet. Okay. That's our starting point. So if we're going on our bike ride, that dotted pink line, it curves around and everything. And let's say at the end of the trail, we know we've gone 3 miles. So that's our distance, okay? But when we look at where we've ended up compared to where we started, where we ended up is at the end of the green arrow, at the end of the path of the green dotted line. So we're at the very bottom. Okay, so when you look at the distance between that arrow and the starting point, okay, up above where the dotted line started, maybe that's only 1.5 miles. Maybe you wound up leaving the roadway and you did travel 3 miles, but maybe you came out on the road only about 1.5 miles down the road, because you can see the green line is not as long as the pink. Okay, so that would be the difference between distance and displacement. Also with displacement, you always have direction. So if you were to look at this example, you would probably say that they went 1.5 miles, and that would be southeast. And just a reminder, you guys will have access to your computer, so you can do this, but I always have students come to me and they don't remember. North, of course, at the top. South, we have east to the right, and west. So you might want to make notes of that because we will be adding directions when we do our problems. It's not always easy to determine, but it's good to have those. So let me clear this off. Okay. And we'll go back to talking about distance. Okay. If a runner runs a 2-mile track and ends up where he started, what is the runner's distance and displacement? So, just to review, distance is how far the runner moved. In this case, it tells you he runs a 2-mile track. So the distance part is easy, 2 miles. Okay? When we're trying to determine displacement, we're looking at the difference between the ending point and starting point. So he started at 0 and he ended at the same spot, which is 0. So did the runner have any displacement? No. His displacement was nothing. He started and ended at the exact same spot. Okay, so here's another example, and I'm going to shrink that down a little bit so I can do an illustration for you. Because when you do distance and displacement problems, if you do an illustration of them, 9 times out of 10, you can see the answer when it can seem really difficult just reading it. So please always take a second to write out visually what they're telling you. So if a soccer player runs 50 meters north, and I'm going to just draw a not quite so straight line, and this is 50 meters, okay? And then turns around, which means going back on the same path, and we'll just do it like this, and runs 20 meters. Okay, if this is the start, okay, and this point is your end, okay, what is distance and displacement? Okay, let me get back over here so I can click. Distance is how far the soccer player ran, and we can see in our example that he first ran 50 meters north but then came back 20 meters. So you're going to have a total of 70 meters and that's your distance. Now displacement, a little bit different. We're looking at where they ended up, and we can look at our point versus where they start. And it's going to be the difference between that end dot and that start dot. And how do we know how much that is? Well, we know the whole arrow has to be 50 meters long. And if the soccer player came back 20, it means this area right here must be 30 meters. And that is your displacement. Okay? All right. You also could have subtracted the 50 minus 20, whichever works for you. Okay, so we've got 30 meters. Also, when you are working with displacement, always direction. And sometimes this part confuses students because the last direction that the runner or soccer player was going was south. So they may say, oh, 30 meters south, but that's not true. It's always in reference to where you began, okay? So if you started down here, okay, then where you ended up is actually north of where you started. Okay. Alrighty. So let's go ahead. Let me close that. Okay. So when we talk about things like distance, displacement, speed, we'll look at velocity and acceleration tomorrow. We'll also go into acceleration on Wednesday. What exactly does scalar and vector mean? Scalar quantities are quantities that have only magnitude, and that just simply means an amount. So when we're looking at the two items that we have talked about so far, distance and displacement, the scalar quantity of the two would be the distance because it only has magnitude. You ran 2 miles. Let's say you went on a trip and went 500 miles away. Okay, so it's a scalar quantity. It only has magnitude. A vector quantity has a magnitude and a direction. And the perfect example for right now for us is displacement. because notice that every time you talk about displacement, you have a magnitude or an amount, but you also are telling in what direction. Okay, so we have looked at the example of the mountain bike ride and how we did our little curvy path, and we're trying to figure out distance and displacement. Now, occasionally when we're working out problems, we will find, okay, times where the problem may say something like this. You have a truck and you traveled 3 miles south, okay, and then you traveled 7 miles east. Whoop. Okay, let me put an I there so I know it's miles and not meter. So if you start here and you end here, okay, your displacement is actually going to be this right here. And if you'll notice, we've drawn a right triangle, so that is the hypotenuse of a triangle. This is not going to be for every problem that you solve, but occasionally you will be able to use the old Pythagorean theorem. And I know you've dealt with this in math class. And that's the old a squared plus b squared equals c squared. When we are looking at the side of the triangle that shows the object's displacement, it is going to be the hypotenuse, or the c. Okay, so let's do an example of a problem that makes use of Pythagorean theorem. Let me clear that page. Okay, we have a delivery truck drives 4 miles west. So remember, west is going to the left. So let's draw it. Remember, always draw it. We've got 4 miles, because when you draw it, it helps so much. Then it says you turn right and drive 6 miles north. I'll make this as straight as I can. So let's say this is 6 miles. So this is our start. And this is our finish. Okay, so then it says find the distance and the displacement. So our distance, when we're looking at distance, is just how far the truck went. Well, it went 4 miles on one path and 6 miles on the other, so 6 plus 4 should give you a total of 10. All right, when we look at displacement, we're comparing the difference from our start to our finish, so it's going to be the hypotenuse of this triangle. Okay, so what we're going to need to do is first write out our equation. A squared plus b squared equals c squared. Okay, and in this example, we'll make this our A, our B, and our C. Okay, so we put our 4 in for your A leg, 4 square, and then we put our 6 in for our B, 6 square, and it should equal c squared. So then once we calculate out 4 squares 16, 6 squares 36, we add them together to get 52. Now we're not done though, because we're saying c squared is 52, so that means we have to get the square root of 52 for a correct answer. If you plug that into a calculator or into your computer, your answer should be 7.21. Now we're talking about the units miles, okay, but we also have to have a direction when we're talking about displacement. So when you draw it out, this helps tremendously. If you look at your start as your reference point, your finish, and let me draw this out, or quick cheat sheet right here. Okay, we've got east and west. So we've gone in this direction, okay, and it's between north and west, so it would be northwest. All right, just as a reminder. Okay. So let me expand that back up, and I think we are done for today. That covers distance and displacement. I've got a few problems for you to work out. I hope you have a wonderful day.